So welcome everyone. Welcome to the fourth class of this live class session. So in the first three classes, we did very specific thing that how to find magnetic field. How to find magnetic field. Okay. So we focused on finding magnetic field. Okay. Although we are not completely done because there are two ways to find magnetic field. One of them is known as Biot-Savart's law. And another way of finding magnetic field is known as Ampere-Circuital law. So we have done Biot-Savart's law, but we have not done Ampere-Circuital law. We will do it later on. But now I want to shift the focus. Now I am not interested in finding magnetic field. So let's say I already have a magnetic field. So I have a magnetic field. Somehow I have some sort of magnetic field. How it came, I don't know. You don't have to worry about how this magnetic field came. Maybe this is because of the magnets. Maybe this is because of the earth magnetic field, or maybe this is because of some charged or some current body. You don't have to worry about it. So magnetic field is already there. So magnetic field is already there. Okay. In the region, in some region. So there is some magnetic field in this region. So let's say this is your magnetic field. Okay. So this is your magnetic field. And in this region, the magnetic field is already there. The question now I'm going to ask you, okay, so if I have some charged particle, so let's say I have some charged particle Q, and this charged particle is moving in this field. So charge particle Q, mass M, moving in this field with velocity v. Okay, with velocity v. So let's say this charge particle is moving with some velocity v. Then what will be the force on this charge particle? So if the charge particle is moving in a magnetic field, then what is the force on this charge particle? And the formula for that is given by F vector equals to Q V cross B. Okay, so this is the formula. This gives you the formula. Force equals to Q V cross B. Okay, so Q is a charge, V is a velocity vector, B is a magnetic field vector. You do this and you now know what is the force which is acting on this charge particle. If this charge particle is moving in a magnetic field, magnetic field was already there in this region because of something. There was already magnetic field in this region and the charge particle is moving in this region. So it is experiencing force F equals to Q V cross B. Okay. Now, can you tell me the properties of this force? Basically, what are the features of this force? If the charge particle is at rest, then velocity is zero. Then the force is also zero. Then the magnetic force is zero. Okay. Okay. Number one, what is the properties of this force? Anyone? Start telling me. It's a circular motion. No, it's not a circular motion. Many other possible motions are there. It cannot change the kinetic energy of the particle. Okay. So work done by the force will be zero. So magnetic force never do the work. So if you will ever find the work done by the magnetic field, okay, so work done by the magnetic force. So work done by the magnetic force. So let's say, what do I mean by work done by the magnetic force? So let's say I have some charge particle Q, and this charge particle Q goes from position 1 to position 2. So it goes from position 1 to position 2 because of this magnetic field. So this magnetic field, because the magnetic force is acting on this particle, so this particle will change its position. So the position of the particle is changed. So this particle goes from one position to some other position. And if you will find the work done by the magnetic field or the magnetic force, it will always come out to be 0. It will always come out to be 0. So you know what is magnetic force, so you know what is work done, force into displacement ka integration. So this will always be 0. Okay. So if the work done by the magnetic force is always 0, then it means the change in kinetic energy will always be 0. Because you know work energy theorem, work done is equals to change in kinetic energy. Work done equals to change in kinetic energy. It means if your charge particle is moving inside the magnetic field, its kinetic energy will never change. Kinetic energy will not change means speed will not change. Speed will not change. Only direction can change. Direction, or you can say velocity, can change. Okay, so what do I mean by that? So let's say I have a magnetic field. So let's say the particle is actually moving with a velocity of 10 meters per second, and there is some direction. So after some time, it is possible that the velocity vector will change the direction. So the direction of velocity vector can change. So this can happen. The direction of particle can change, but the magnitude will not change. The 10 meter per second will remain 10 meter per second. So if your particle is inside the magnetic field, its speed will not change. Never. It will never change. Its kinetic energy will never change. Magnetic field is not capable of accelerating the particles, means increasing the speed. Its velocity can change, means and velocity can only change because of direction, not because of magnitude. So that is the point. Okay, so now let's have a very quick proof of this, like why this is happening. So what is the reason for that? So you know work done is given by force into displacement. Okay, now force is given by q v cross b dot r. Okay, now velocity v cross b dot r, this is a situation that you have. Okay, now in whatever plane your velocity is there, so let me put this in a very simple way. So let's say your velocity is in x-axis. Okay, just for a simplicity, your velocity is in x-axis. For magnetic field is in y-axis. Velocity is in x-axis, magnetic field is in y-axis. This is magnetic field, this is velocity. If you do v cross b, then you will get z-axis. Means the force is upwards. The force is going to be upwards. That is what is going to do. Force is going to be upwards. Okay, that is what is going to happen. And when you do the dot product of, okay, so we will have this proof when I will be teaching you the circular motion. Let's not confuse right now, otherwise you will get confused. So for now, let just agree on my situation, and then we will have this discussion. We will have, don't worry, I will explain you that. Don't worry. There is a very simple, I can give you mathematics right now, but we will even have more than mathematics. Okay, but right now just agree with me. The very simple proof is the mathematics proof I can give you. So work done is given by force into displacement. Okay, and force is given by q v cross b. That is a very simple proof, v cross b dot dr. And now what I can say is the velocity you know is given by dr by dt. Right, velocity is given by dr by dt. So what is going to be dr is going to be v dt. Okay, so dr is going to be v dt. So if you put v cross b dot v dt, how many of you believe that this is 0? How many of you have no doubt that this is 0? What do you think? How many? This is very fundamental mathematics. Or how many of you have doubt, or you have no doubt? So write the comment. Some, if you have doubt, write doubt. If you have no doubt, write no doubt. How many of you can see that this is not 0? This is perfectly 0. Doubt. Okay, one person has a doubt, no problem. Simple. Okay, so you see cross product. So few people have doubt, so cross product. So you see when you do a cross b, when you do A cross B, so let's say V cross B, let's say. So let's say V is in X axis, B is in Y axis, right? Then X cross Y will be in Z direction. V is in X direction, B is in Y direction, X cross Y will be in Z direction. So this vector V cross B will be in Z direction. Now dot. Now you are doing here dot product. You see dot product. Dot product with who? Velocity. So velocity is in x-axis. So you see z dot x will be 0, right? Dot product of two different unit vectors is 0. Perfect. So that is why this is 0. So this is a very simple mathematical proof without any looking into the physics. I mean, this is a mathematical proof because if vectors are true, then this has to be 0. But I have not given you a way of thinking. So I will even give you the way of thinking, but when I will be explaining you some application, okay, not now. So number one property of this force is that work done by this force will be 0, which basically means कि if your particle is moving in this, if particle is moving in magnetic field, the speed of the particle cannot change, kinetic energy of the particle cannot change, only the direction of the particle can change. ठीक है? Only the direction can change. That's all. That nothing else. Very simple idea. Okay. What is the second property? This is the first property. What about other property? Anything else? What do you say? No, tangent to what? Pranjal, your question is incomplete. Tangent to what, right? The force is always perpendicular to the direction of motion. Okay. ठीक है. That is okay. Force is always perpendicular to the direction of motion. ठीक है. But these all are the application based. We will talk about it. But what are the fundamental properties of this force? Fundamental properties. Is this force conservative or non-conservative? Is this force conservative or non-conservative? Conservative means the total energy of the system will remain constant. Non-conservative means the total energy can change. So is it conservative or non-conservative? In general. Okay, why is it conservative? Why is it conservative? Why do you think it's conservative? Okay, so you thought about kinetic energy, but what about other energies? Kinetic energy is not the only energy. In the total energy, you have also kinetic energy. Total energy, you have also uh, potential energy also. So what do you think? What is a what vector algebra सबने पढ़ा है, I think. So in vector algebra, what is the thing that you have to follow? What is one thing that you, if you follow, we can say that it okay, it's a conservative. So you know, if del cross f is 0, then f is conservative. Now you tell me, is del cross b 0 always? Is del cross b always 0? What is del cross b? How do you define del cross b? Can you define? Is there any way to define? So del cross b is equals to nu naught j. This is Ampere's law, Ampere circuital law. We will talk about it. We will talk about it. So we will talk about it. But in general, I can say that this force is not conservative. And how do I know? By directly looking at it. 99% of the times. No, you are wrong, Kritna. Even if it is time non-varying, even if it is time constant, even then magnetic field is non-conservative. Magnetic force is always non-conservative in general, time independent or time dependent. That is for electric field. Electric field is conservative if it is time non-varying, and if it is non-conservative if it is okay. So that rule applies in electric field. Okay. Non-conservative. How do I know that it was non-conservative? 99% of the times, if any force contains velocity, then it is non-conservative. If it is a velocity dependent force, if any force is a velocity dependent force, then that force is going to be non-conservative. Perfectly fine. So that is one of the very and you can even have a proof of this in any standard book. But non-conservative forces usually have velocity dependence in them. The forces which do not have velocity dependence, for example, gravitational force. Gravitational force does not depend upon velocity. It only depends upon masses and the distance between them. What is a velocity? It does not matter. Perfect. And similarly, electrostatic force. Electrostatic force is also basically not velocity dependent. That is why that is also conservative. Okay, next question. So it's non-conservative. What about, is it central or non-central? Is it central or not central? Is a central force? It's a non-central force. What is non-central force? Non-central force means that, let's say you have electrostatic force. So positive charge, negative charge. So the line joining between them is this. This is a line joining between them. The force is also acting on this line. So this positive is attracting and this negative is also attracting. So you see the forces are along the line joining them. So the line which joins the two particles, the force acts along that line. But if the force does not act along that line, force acts in some other direction. So let's say this is your charge particle 1 and force is acting on some other direction. It is not acting on the line joining the two charges or two particles. So this is non-central force. Okay. Now, there is an interview question based on the property number 1. So everyone agreed with me on property number 1. Property number 1. So everyone said that work done by the magnetic force is 0. Okay, I have a very simple question. This is a land and this is some iron body, iron object. Okay. And then you have a crane, right? And this is a magnet, huge magnet. So this crane with a magnet comes on top of this iron object. As a result, this iron object moves up and gets stuck with it. Right? This you must have seen in the industrial work. What you see, the crane goes with a magnet. The crane have an magnetic magnet, and then magnet pulls everything up. Right? So this goes up. This goes up. I mean, something has happened. Then who did the work? Who did the work? I mean, magnetism cannot do the work. Then who did the work? Who picked this up? No. So work done by the current means work done by the magnet only, because magnet is made of current, right? So you cannot separate them. So there are only 2-3 forces here, and think about it. Work was done, right? Obviously, because iron block is up, raised up. So iron block was on the bottom. It moves up. So work has happened. No one can say the work has not happened. No, there is no EMF or anything like it. It's a pure magnet. Yeah? EMF कहाँ से आ गया? Current और EMF आया कहाँ से? This is a pure magnet. This is magnet. Huge magnet. Nothing else. I'm not talking about electromagnet or any. It's a huge magnet. Magnet comes and then it picks the iron. Who did the work? Magnetism cannot do the work. Then who did the work? Gravity did the work. This is a very mind-boggling example. Iron block moved against gravity to go up. I mean, you have to think about it. The iron block moved against gravity but still the work is done by the gravity. This is a very, very stupid line which I'm saying, but this is true. And you have to think more about it and search about it. Okay, I'm not going to explain this, but you search about it. I'm asking you a very simple question, and this is even in a Griffith's book has this question: who did the work? If a magnet pulls an iron object, then who do the work? There are three possible options only. Magnet, which is not possible because magnetism never do the work. Second, gravity, which is counterintuitive because iron block is moving against gravity. Then how can gravity help him? If iron block is moving against gravity, then how can gravity help him? Okay. Third, normal forces or other forces, like whatever you can think about, like mechanical force or normal force and so on. Okay, so think about it. Who did the work actually? So you have to give me a correct answer in the Telegram community. Okay, perfectly fine. So now with one statement moving forward, then what is the statement? Inside a magnetic field, speed or kinetic energy cannot change. Direction change. Direction can change. It means in physics, whenever you will use magnetism, whenever you will use magnets, the main purpose will be to change the directions. The main purpose will not be to give energy to the system, because you cannot change kinetic energy, you cannot change the speed, all you can do is change the directions. Okay, so now we have three cases. Okay, motion of moving charge, motion of moving charge in magnetic field. So today I'm going to give you derivations, not derivations, sorry, basic idea. And tomorrow we are going to solve three very difficult problems. I mean, today we will have basic problems and basic idea. Tomorrow we are going to discuss very, very difficult problems on this concept. I mean, which usually you do not find very easily in the books, but we will do it. So for today, let's have a very basic idea. Motion of a moving charges in a magnetic field. Okay. So there are three cases I'm going to explain you. Case number one. So this is case number one. Velocity is parallel to magnetic field. Velocity is parallel to magnetic field. So let's first of all draw magnetic field. So this is your magnetic field. So a very good feature about the magnetic field is that I am taking a uniform magnetic field. I'm not taking non-uniform magnetic field. In your syllabus also, you also only had to take uniform magnetic. Uniform magnetic field means everywhere the magnetic field is same. So if you're here, or if you're here, or if you're here, everywhere the magnetic field has the same direction as well as the same magnitude. Okay. So it does not change with time. It does not change with position. No change with time, no change with position. Magnetic field is same everywhere. Number one case is that you have a charge particle whose velocity is parallel to magnetic field. So this is your charge particle, and your charge particle is moving parallel to magnetic field. So what is the force acting on a charge particle in this case? Yes, everyone. What is the force going to be? So zero, because you see, whenever velocity and whenever the two vectors are parallel, their cross product is zero. Two parallel vectors always have a cross product zero. It means force acting on this particle is zero. It means I can say 2-3 words about this. So the charge particle has no force. It means the charge particle will just keep moving in the same direction. Newton's first law. A particle will keep moving in the same direction as long as no external force acts on it. A particle at rest remains at rest. A particle which is moving will keep moving if no force is acting on it. Since no force is acting on it, so the charge particle will just keep moving in a same direction. So you can say two words. Number one is undeflected, or you can even call it as straight line. So there are two words which comes into picture in this context. Yes, very quickly, everyone is okay with this. This is very simple. They are not going to ask you this. Okay, can we move forward? Yeah, clear as a, okay, perfect. Second, Case 2, velocity is perpendicular to magnetic field. Okay, so now I am again going to draw magnetic field, right? Again going to draw magnetic field, and now I am going to have a charge particle perpendicular. Okay, so this is my charge particle. So velocity is perpendicular. Perpendicular. Okay, so this is your velocity, and this is your magnetic field. The better easy way to do this will be by drawing some different diagram so that you can understand better. So let's say the magnetic field is actually coming out of the plane. So magnetic field is coming out of the plane. So whenever something is coming out of the plane, we draw it with the circle. And if it is going inside the plane, we draw it with the cross. We know that. Okay. So magnetic field is coming out. Coming out means K cap. K cap. Okay. And now you throw a particle with some velocity. Now, how is this particle perpendicular? Because you see, this direction is x-axis. So velocity of the particle is x-axis. You see, I cap and k cap are perpendicular to each other. You know that. X, y, and z are perpendicular to each other. So particle is moving in this direction along the east, you can say, and magnetic field is coming outward. So basically, the particle is moving in this plane which you can see, but the magnetic field is coming out of the plane. Okay, so very simple idea. Now, if I find out the magnetic force, so it is going to be QV cross B, QV cross B. So if you do that, you get QVB, and V cross B, I cross K is basically minus J. It means force is acting downwards. So force is acting like this. Force is acting like this. Okay, downwards. J cap minus J cap basically means south. And this is east. In physics, very important theorem is that if velocity and force are perpendicular to each other, then the motion is circular. Then the motion is circular, and force act as centripetal force. Act as centripetal force. So in physics, whenever the velocity and force are perpendicular to each other, in this case, you can clearly see that force and velocity are perpendicular to each other. So the motion of the particle is going to be circular. So I can even show you that. In a circular motion, you see, if let's say I am in a circular motion, I'm moving clockwise, right? So let's say this is my velocity, then I come here, then this is my velocity. I come here, then this is my velocity. When I reach here, this is my velocity, right? So your particle is moving in a circle, and these are the directions of velocity. Now there is something known as centripetal force. Centripetal force basically means can be any force. In this universe, every force has an ability to be centripetal force. Centripetal force is some normal force, you know, like tension or gravity or electrostatic, which in a particular situation is causing a circular motion. So any force, any general force which is causing a circular motion, we call that force as a centripetal force, because that force in this case is responsible for a circular motion. Because whenever we need to do circular motion, someone has to apply force. Without applying force, we cannot have a circular motion. Circular motion is impossible without a force. Okay, so centripetal force always acts towards the center, you know that. So you see, acts towards the center, acts towards the center, acts towards the center, acts towards the center. At all the locations, you can see the force and velocity are perpendicular. 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 Centripetal force always acting towards the center. Velocity is acting tangent. So at all the positions, they are perpendicular to each other. So what we learned in this case is, in physics, whenever the velocity and force are perpendicular, the motion is going to be circular. And in this case, exactly that is what is going to happen. That is exactly what is going to happen, because velocity is perpendicular to magnetic field, or you can say, when you will find out that velocity is also perpendicular to force. So if velocity is perpendicular to the force, then the motion is going to be circular. Okay. Any doubt till this point? Then we do the mathematics. Yes, is it clear till this? Most of you might have done this already. It's just a basics. Yeah. Any doubt, please go ahead. If you have a doubt, you are new to the topic, please let me know. Say doubt, I will explain again. Clear everyone, to the new people? No. Central force is not always centripetal. No, that is very wrong idea you have. There is no central force. This is not a central force. Central force does not mean which act towards the center. Central force has a different meaning. Set. Okay. Okay. Next point. Let's do mathematics. In physics, whenever you see a circular motion, okay, so now I am going to come to the circular motion. Very simple line. So circular motion happens whenever the velocity is perpendicular to force. There is a same mathematics whenever you see a circular motion. So what is that mathematics? Whatever force is acting, you equate that force with mv square by r. Same mathematics. This mathematics remains same in all the situations. You think about any circular motion, the same mathematics will apply, that whatever force is acting, you equate that force with mv square by r. Okay. Now, the force which is acting is different in different cases. For example, in solar system, gravitational force is acting. So this force will be gmm by r square. Okay, so this force will be gmm by r square. In atom, electrostatic force is acting, so this force will be k q1 q2 by r square. In this case, in our case, the force which is acting is magnetic force, so hence that will be qvb. Why I said qvb, not qv cross b? So that is a very simple idea here, because qv cross b can be written as qvb sine theta. And we are studying the case in which velocity is perpendicular to magnetic field. It means the angle is 90 degree. Angle between velocity and magnetic field is 90, and sine 90 is 1. Hence I can say qvb. So magnetic force in this case is qvb. There is nothing, you don't have to worry about cross product, because sine 90 is 1. Okay. So one thing we learn in the circular motion is, in all the circular motions in the universe, force is always equals to mv square by r, but this force changes depending upon the situation. Okay. So now let's come to our situation. Okay. Our situation. In our situation, the force is qvb, and we make it equals to mv square by r. So one thing that we learn from here is that radius I am able to find out. mv by qb, because this v and v cancels, and radius I am getting is mv by qb. It means the radius of the circle, basically I told you that particle will be in a circular motion. So particle is in circular motion. So if particle is in circular motion, then there must be some radius, and the radius is given by mv by qb. Now you have to tell me, is this radius constant or changing? Constant or changing? Why it is constant? Because it depends upon velocity, right? Speed. It depends upon speed. So speed is not changing. Speed is changing or not? No, because we just talked about it. In magnetic field, speed cannot change. Mass cannot change. Basically, the particle's mass is not going to change. Speed is not going to change. Charge of the particle is not going to change. Magnetic field is also uniform. So hence this radius is constant. So in a fixed radius, this particle will just keep on moving. Will just keep on moving. Okay. Perfect. Second. So this is one formula that you need. Now, second question that I can ask you is time period. How much time it will take to complete one circle? In circular motion, this is the same formula every time. So if you see circular motion in any chapter, the formula is same. So time period is always given by distance upon speed. Time is always distance upon speed. So if you complete one circle, the distance is going to be 2 pi r. And the speed is constant. How much is the speed? V. V is the speed. So 2 pi r by V. So now you put the value of radius. So radius is going to be mv by qb. So V and V cancel, so you get 2 pi m by qb. So this is the formula. So radius has a formula mv by qb. Time period has a formula 2 pi m by qb. But sometimes this formula is also written in different ways, because not always the speed is given to you. Sometimes the momentum is given. So if momentum is given, then you have to write this formula as momentum by qb. Sometimes you have to rewrite this formula, because if velocity is not given, let's say speed is not given to you, in that case momentum may be given to you. So momentum is given, then you have to write this formula as momentum by qb. Okay. Next, sometimes the kinetic energy is given. Sometimes speed is not given, momentum is not given, kinetic energy is given. So you know kinetic energy is given by p square by 2m, right? So p can be written as under root of 2mk. So what I'm going to do is put momentum here. So if you put momentum here, you get under root 2mk by qb. Under root 2mk by qb. So these are the different ways of writing this formula. Okay. So one way is in writing in terms of speed, one way is writing in terms of momentum, one way is writing in terms of radius. Okay. So that is an idea. Perfect. Okay. You don't have to worry about time period, because time period does not involve speed or momentum as such. You don't have to worry about that, because time period only depends upon mass, charge, and B. Okay. It does not depend upon how much is the speed of the particle. So if the speed is slow or more, the time period is going to be same, as long as mass and charge is everything is same. So these are the three formulas of radius. Now I'm going to give you some basic questions, and then see how you can tackle that. So you have two particles. Number one particle is proton, okay, and number two particle is alpha particle. Okay, both of them have the same kinetic energy. I'm telling you, this is what I'm telling you. Both of them have the same kinetic energy. So kinetic energy of proton is same as kinetic energy of alpha particle. Now you have to tell me what is the ratio of radius. Basically, proton will move in a circle. Alpha particle will also move in a circle. So what is the radius of their circles? Are they going to move in the same radius, or what is the ratio? Okay. So solve that. You can use this formula if you want and give the answer. Let's do it. So proton has one proton. Basically, proton is just one proton. The charge of proton is plus E. Mass of proton is mass of proton. Simple. Okay. 1 am you read. What about alpha particle? Alpha particle is helium 2 positive. Helium में से 2 electrons if you remove, so you are only left with this helium nucleus. That is called as alpha particle. Now helium has 2 protons and 4 mass, right? Mass is 4 because there are 2 protons, 2 neutrons in a helium. The mass of the helium is 4. So the mass of the helium is 4 AMU. But the charge of the helium is 2e. 2e, because you see the 2 electrons are removed, so it is 2 positive. So the charge of helium, or you can say alpha particle, is 2 positive. And finally Sakshi gave the correct answer. Finally, after 20 answers, I got one correct. Mass is 4 AMU. Okay, and now let's compare. So kinetic energies are given, so use the formula for kinetic energy. That is why I gave you the 3 formula. Use the formula for kinetic energy. Okay, so first rp is 2 mk by qb. Okay, perfect. 2, mass is 1, kinetic energy is kinetic energy, and q is 1, and magnetic field is magnetic field. So basically you get under root 2k by b. Now you find alpha particle. So 2, mass is 4, mass of alpha is 4. Kinetic energy is kinetic energy because kinetic energy of both is same. Charge is 2 and b is b. Now you take the under root of 4. Under root of 4 is taken out, you get 2. Inside you have 2k and you have 2b. 2 and 2 cancels, you get under root 2k by b. So you can clearly see that proton and alpha particle have the same radius. So the ratio is 1:1. I don't know why you were not able to solve this. Okay, what was the doubt? Now you tell me the doubt. This is a solution in front of you. I mean, and this is an NCERT question of class 12, nothing more. NCERT question. So any doubt here, please go ahead. अगर अभी किसी को नहीं समझ आया, there is not going to be second chance. So अभी समझ लो. Then rest of the life you will be safe. Yes, go ahead. Is it clear to you all? 1:1. G. Yes. Okay, perfect. More questions. Let's do more questions. I mean, I thought one will be enough, but let's do more. Okay, let's do more. Again, proton and alpha particle. This time they have the same momentum. This time they have the same momentum. They don't have the same kinetic energy, they have the same momentum. Then what is the ratio of alpha, proton and alpha? You can use the formulas. Write it in your notebook so that you can always use them. Okay, now you tell me. Now you are all getting the correct answer because you see radius is given by p by qb. Okay, because in this case the momentum is given same, so I will be using the formula for momentum 1. So rp by r alpha is actually basically radius is inversely proportional to charge because momentum is same, magnetic field is same, radius is inversely proportional to charge. So rp by r alpha is going to be q alpha by qp. Charge on alpha particle is 2, charge on proton is 1, so the ratio is 2:1. Okay, very simple question. Now you all understood. Okay, chaliye. Next. Okay, today I am not going to discuss very difficult problems. Today we are going to solve very simple things, and then tomorrow we will have difficult problems. But today we will complete the topic. Third case. So we studied that angle is 0 degree basically. Then we studied the case where angle is 90. Which angle? Angle between velocity and magnetic field. So velocity is parallel to magnetic field, and in this case velocity is perpendicular to magnetic field. Now we will see something in between, not parallel, not perpendicular, but some angle. Case 3. Then velocity is at some angle with magnetic field. okay, with magnetic field. Let's say that angle is theta. So now what you see here is you have a magnetic field here. So let me draw magnetic field. Okay, so I'm drawing magnetic field, and this is your velocity. So velocity is at some angle theta. So now I can solve this problem by mixing the first two cases, because velocity has two components. One component is parallel component and the second component is perpendicular component. Basically this component, which is v cos theta, and this component, sorry, this is v perpendicular, v sin theta. So this is my case number 1 and this is my case number 2. Case number 1, case number 2, right? Because now velocity has both components, parallel as well as perpendicular. So I will see the combination of both. What was the combination of both? So this is my v parallel, v cos theta, and this is my v perpendicular, which is v sin theta. Because of the first case, if you remember, the motion was straight line. And because of the second case, the motion was circular. Now I combine both. So if you combine circular with straight line, you get helix. Helix. Helical motion. So basically what happens is, this is what is going to happen. So you are moving forward because of v parallel, and you are moving in a circle because of v perpendicular. So in the second case, it was circular in just one place. You are not moving forward. You were just moving in a circle in one place. In the first case, you were just moving forward, but there was no circle. Now it is both. You have circle as well as you are moving forward. Okay. So now you can be asked few things. There are few things which can be asked here. Number 1, what is the radius of this circle? So radius of circle will be mv by qb. But in this case, v will be v perpendicular, because the circular motion is because of the v perpendicular. That is why the formula will become mv sin theta by qb. Okay. So in this case, the radius is not mv by qb, it is mv perpendicular, because the circular motion is only because of the perpendicular velocity, and perpendicular velocity is v sin theta. Similarly, you can be asked what is time period. Time period is not going to change. That is going to be 2 pi m by qb, because that does not depend upon speed. And the third question which they can ask you is pitch. Pitch. Now, what is pitch? Pitch is that how much you move forward by the time you complete one revolution. So let me write this. How much you move forward, how much you move forward by the time one circle is completed. Okay, one circle is completed. So one circle is completed. So by the time one circle will be completed, you will also move somewhat forward. So this much you will move forward, and that is known as pitch. So pitch. Now you are moving forward. So pitch means, pitch is a distance basically. So pitch is a distance, right? And distance is given by speed into time. Speed into time. Now which speed? Parallel speed, because you are moving forward because of the parallel speed. Parallel, just because of the parallel speed. You are not moving forward because of any other velocity. You are just moving forward because of the parallel speed. And by the time you complete a circle, the time to complete the circle is given here. You see, the time to complete the circle is given here. So that is your formula. So v parallel is what? V cos theta, and time period is what? 2 pi m by qb. So that is the formula for pitch. Pitch. Okay. So simple idea. That is a formula for pitch. Clear? बहुत basic. No difficult questions I did. Very basic theory only I covered. It's okay. Everyone okay with this so far? I mean, that's all. You don't need to know anything else. Is okay, everyone? Doubt hai to please ask doubt. Write doubt. I will explain again. Don't worry. If you have doubt, just write out, no worries. If you are clear, just write clear so that we can finish it up. Yeah. Okay, perfect, perfect, perfect. So now, before I end the class, I just want to tell you few things. Number one, uh, if you want to be expert in this concept, means numerical solving, if you want to achieve numerical solving, okay, first of all, if it was your first time learning this and you are very new to this, very new to this, then what you should do is do JEE mains PYQ. And is JEE main PYQ enough? Yes, for just it is enough. I mean, straightforward, you will get many questions of JEE mains. But if you are already, you know the basics, you know the easy questions, and you want to improve yourself even more, okay, then for then you should do Singage electromagnetism book. Okay, so this is a book which is used for JEE Advanced and more than that. So this book has a very fantastic solved examples and very difficult. I mean, if you are very new to this and then you open this book, you are just going to waste your time. So don't open this book if you are new. If you are already very good, if you have already some rank, JAM rank or something like that, GATE rank, then you open this book. Otherwise, I would say just focus on JEE mains, move in steps, okay, and then later on you can open this book whenever you get the time. Okay. And other than that, I would really recommend you all to, if you are not a part of this, then become the part of JEST 25 course, because you can also in parallel learn some other subjects as well. So right after this, I am going to start statistical mechanics. There will be one or two more classes on magnetism, and then we are going to be going for statistical mechanics, and then we will again come back to electromagnetism. So we will move like that in the sequence of most important. Okay, but you can even do parallel topics. If you are part of just 2025 course, then you can even do some other topics. So like image problem and so on, you can do in parallel. Okay. No, I will not be doing anything which is not important, Kritna. This lecture is already there in your course, so you can watch there. Okay.